Hi, and welcome to section 4, Making Our Models Better. In this section, we are going to look at ways to evaluate the model, look at some measures that are better indicator of performance and predictive power than just accuracy. We will learn ways to improve and optimize the model. In this video on model evaluation, we will look at what is a bias and variance, what is bias-variance trade-off, and we will also look at something called as overfitting and then define a set called as the validation set which can be used during parameter tuning. An algorithm is said to have a high bias when it is missing out on important features because of wrong assumptions in the learning algorithm. Let's look at this graph. Here x1 and x2 are my input features and the circle and cross is my output variable. What we want here is to differentiate between the circle and the cross. If we divide the data with a straight line, we can see that this is not the perfect fit in such a situation. When we are assuming that the data can be divided by a straight line when in fact it cannot be, we call it a high bias problem. On the other hand, we have the high variance problem. In this, the learning algorithm is so sensitive to the fluctuations in the training data that it tries to fit the data perfectly. A high variance problem can cause an algorithm to model the random noise in the training data. Let's look at this graph again. An overfitted line looks like this. What's happening here is that the learning algorithm is so specific to this data that it tries to fit all the data points perfectly. The problem with such a situation is that if we try to test it with a new data, it will fail. What we instead want is a perfect balance between bias and variance. And if we have a good balance between bias and variance, we get a graph similar to this. A good way to approach bias-variance trade-off is that when the bias is high, we can increase the model complexity by introducing more number of layers with a large number of neurons. When the variance is high, we can increase the data or use regularization. We will cover regularization in the following videos. The high variance problem is also called as overfitting. Overfitting is a modeling error in which the function tries to fit too closely to the training data. What happens in a real-world scenario is as you keep increasing the model complexity, the prediction error on the training data keeps reducing. But at one point, if you keep increasing the model complexity, the test data prediction error starts to stagnate. After the point, it also starts to increase. This happens in the case of overfitting. In the previous example, we just made use of the test data to make assumptions about the learning algorithm. In a real-world scenario, we cannot use the test data set. So to tune our hyperparameters and parameters, we are going to make use of validation set. It is equivalent to the test set in the sense that it will not be included in the training data. We split the data into 60, 20 and 20, where 60 is the training data, 20 is the test data, and 20 is the validation data. We can use some other splits like 80, 10 and 10 for the trained, test and validation sets respectively. So there is no fixed rule to it. The validation set can also be small in case the training data set is really large, in terms of millions. In that case, a validation set of let's say 10,000 data points is good enough if it is representative enough of the population. In this video we saw how can we evaluate our model